Okay, we are in section 9.3 where we are going to use the Pythagorean theorem. So if the Pythagorean theorem is new to you, the Pythagorean theorem is derived from a right triangle. So right triangle means that one of the sides has a 90-degree angle on it. And we are told that for any right triangle, the sum of the squares of the legs are these two sides here and here, side A and side B. Those are the side lengths that are basically touching the that 90-degree angle, is going to be equal to the square of the length of the hypotenuse. So the square, the sum of the legs, is equal to the square of the length of the hypotenuse. All right, more commonly known as a squared plus b squared equals c squared, where a and b are our two legs and c is the hypotenuse. All right, some of the things that we have to know about those values of A, B, and C. Like I said, A and B are the two side lengths that touch that 90-degree angle. Uh, C, the hypotenuse, is the one side length that doesn't touch. And another note that C will always be, it'll always be the largest side measurement. Okay, so if you have measurements of whatever it happens to be, 3, 4, and 5, for instance, 5 is the largest number. That means that 5 is the hypotenuse. So that's where that comes from. And what we can do in order to find a hypotenuse, or if we are able to find uh, a side length, because usually what happens is you're given two of them, we have to find the third. So let's say, for instance, we are trying to find C. So in order to find C, that means we are given A and B. So in order to find C, in this case, it's going to be the square root of A squared plus B squared. All right, so that's where it kind of comes into uh, finding the square roots. And for today, like yesterday, we want to find the exact answer. All right, so we're looking for the exact answer. So then we have to take into account the different things that we looked at from yesterday in order to help us find the missing side length. Okay, so I got these two examples here. It says, let's solve the following together using the Pythagorean theorem. So here's our Pythagorean theorem right here. What I'm going to ask you to do is when you start solving these problems, knowing that they are right triangles like these two, we are going to start out by writing out the general formula, the formula that's above. A squared plus b squared is equal to c squared. All right. We know that c squared in this particular instance is our missing one, so we know that 10 and 24 are going to represent A and B. All right. What I usually do is I pick the smallest number for A and I pick the middle number for B. You know, they absolutely, you could put A is 24 and B is 10. It's not going to make a difference, but just to keep things consistent, that's what I would do. So in this thing here, we're going to represent this as A. We're going to represent this as B. So we're going to substitute them in. So this is going to turn into 10 squared plus 24 squared is equal to C squared. All right. So now, because of order of operation, we are going to take care of the exponents. So 100, or I'm sorry, 10 squared is 100. And 24 squared is 576, and that's going to equal c squared. All right. So when I add these together, I get 676 is equal to c squared. And all we got to do now is take the square root of both sides. So square root of c squared is c, and the square root of 676 is 26. And it's written, labeled as centimeters, so 26 centimeters is our value of c. Looking at the next right triangle to the right, we are missing a. So in a squared plus b squared equals c squared, this is our unknown. So I look here, 25 is the opposite side length of our 90 degrees. I know that that's our value of C. That means that this is our value of B. So substituting the known values, we get A squared plus 20 squared is equal to 25 squared. All right, just like what we did in the previous example, uh, we're going to take care of the squares. So I got a squared plus 20 squared is 400, and 25 squared is 625. All right, now in order to solve for a, we have to subtract 400 to both sides. So now I got a squared is equal to 225. Take the square root of both sides, so now the square root of a squared is a, and the square root of 225 is 15, and it was labeled as inches. Okay, and those were both exact answers. We just so happen to have perfect square numbers that we get the square root, all right? So that made it nice. So trying this one on our own, same idea. We know it's Pythagorean theorem, writing it out to start off with. We know that this is the opposite value, so that's our largest value. So it's telling us that our unknown is a again, plus 10 squared is equal to 12 squared. So when I square out the numerical values, I got a squared plus 100 is equal to 144. Subtracting 100 to both sides, I get a squared equals 44. If I take the square root of these, I get a equals, now in this scenario, 44 is not a perfect square number. So now in order to get the exact value, we must split up 44 into two products, one of which is a perfect square number. So I can write this as a is going to equal 4 times it by 11. 4 times 11 is 44. So that means that a in this case is going to be 2 because square root of 4 is 2. Put that to the outside, times by the square root of 11. And it was millimeters. Okay. The final thing that we're going to look at that is going to also utilize the Pythagorean theorem is they want you to determine whether the triangle with the given side lengths is a right triangle. So they call this method the converse of the Pythagorean theorem. So what they state is that if you have three side measurements and that happens to fit in the Pythagorean theorem, a squared plus b squared equals c squared, and it holds to be a true statement, we can say that those three side lengths do in fact make up a right triangle. So the only thing that you have to keep in mind when you're looking at the three side measurements is what is the largest measurement, because that's going to be your value for C. So if I look at these two examples, 17 is my largest measurement between 8, 15, and 17, so that's C. In the next example, 20, 21, 28, 28 is my value of C. All right, it's not always going to be the last term sometimes, so be careful. All right, so now looking at the first example, you can choose, I like to choose the smallest value for A, so it's going to be 8 squared plus 15 squared is equal to 17 squared. I got to see if this is going to be true. So I got 8 squared, which is 64, plus 15 squared, which is 225. And it's going to be equal to 17 squared, which is 289. So the question is, does 225 plus 64 give me 289? Yes, it does. 289 is equal to 289. That's a true statement. Since it's a true statement, I can say that this, yes, this is a right triangle. Okay. If we look at the second example, again, a squared plus b squared equals c squared. 20 is my smallest value, so I got 20 squared plus 21 squared is equal to 28 squared. I got to see if it holds true. So 20 squared is 400 plus 21 squared is 441, and it's going to be equal to 28 squared, which is 784. 400 plus 441 is 841, which does not equal 784. So yes, they may be triangle side lengths, but no, they are not a right triangle. All right, and that is being able to use the Pythagorean theorem. Hope this helps. Until next time.